Today, we will learn about what are balanced and unbalanced forces and compass. These lessons are found in your student's book, pages 122 to 123 and 155 until 157. So at the end of this video, you will be able to, number 1, differentiate balanced force from unbalanced force. Number 2, explain how compasses work. In our previous lessons, we learned about force and its classifications. It's been said that Newton's first law states that an object at rest stays at rest and an object in motion stays in motion with the same speed and in the same direction unless acted upon by an unbalanced force. But how are these two forces different from each other? Look at the diagram. Balanced force will cause no change in speed in an object. Balanced force is acting in an object on an opposite direction. Do not cause a change on the speed of an object. Example, when a skydiver jumps, he is being pulled down by gravity. At the same time, air resistance is pushing the parachute up. Because the force of gravity pulling down is equal to the force of air resistance pushing up, we can say that the force is balanced. Balanced forces will cause an object to remain stationary or not moving, and continue moving in the same direction at the same speed, as shown in the picture. Now, when an unequal forces acting in opposite directions, this is what we call unbalanced forces. Unbalanced forces will cause an object to speed up, to slow down, or change direction. Example, in a tug-of-war wherein the persons who will pull the rope are not balanced in sizes, the rope will be moving to the group who have greater forces, or people who are bigger than the other. Therefore, an object that moves as the result of an unbalanced force will move in the direction of the greater force. Now, take a look at the following examples. Number 1. Two people pushing the box in an opposite directions. This example is balanced force because the forces exerted in the opposite directions are the same. Number 2. Tug-of-war of the same number of persons. This is also a balanced force. Number 3. Pushing a box in an opposite direction by two people but different sizes. This is an unbalanced force because the forces in its opposing directions are not balanced. One is greater than the other. Number 4. When pushing a box in the same direction as shown in the diagram, it is an example of an unbalanced force. Now, moving on to how compasses work. By definition, a compass is an instrument used for navigation and orientation that shows direction relative to the geographic cardinal directions. This is an instrument run by a magnet. The magnet makes the compass point north. A compass needle aligns itself and points toward the top of Earth's magnetic field, giving explorers and those lost a consistent sense of direction. The north end of a compass magnet is drawn to align with the Earth's magnetic field. While a compass is a great tool for navigation, it doesn't always point exactly north. This is because the Earth's magnetic North Pole is not the same as true north or the Earth's geographic North Pole. The magnetic North Pole lies about 1,600 kilometers or 1,000 miles south of true north in Canada. This thing even more difficult for the compass-wielding navigator. The magnetic North Pole isn't a stationary point. As the Earth's magnetic field changes, the magnetic North Pole moves. Over the last century, it has shifted more than 1,000 kilometers or 620 miles toward Siberia. This is according to scientists at Oregon State University. This difference between the true north and the north heading on a compass is an angle called declination. Declination varies from place to place because the Earth's magnetic field is not uniform. It dips and undulates. These local disturbances in the field can cause a compass needle to point away from both the geographic North Pole and the magnetic North Pole. According to the United States Geographical Survey, a compass needle can even point south at very high latitudes. By using charts of declination or local calibrations, compass users can compensate for these differences and point themselves in the right direction. Now, if you have a compass at home, you can try the exercise found in your student's book, page 157. This exercise is optional. You may do it or you may not. And that ends our lessons for today. Please don't forget to answer your workbook, pages 101, 103, 131 until 133. For more videos, please hit the button below and subscribe. Have a great day and masalamat!